Hello, I hope you're doing well. I've received a few questions regarding physics 0625. That is the multiple choice questions one. So several students have been asking me some questions, and I've realized they are somehow common. So I'll put those questions together, hoping that it can be helpful to you that you are watching me today. All right, so let's look at these questions and then see if they'll be of any help. So question number one here is about a charged rod is placed on a balance and another rod Y is brought close to it as shown in the figure below. So here what you can see is that the initial reading of the balance, we are talking about 45.3 grams. When this charged rod is placed near rod X, then the reading should or increases to 45.7. That means there's an increase of mass by 0.4 grams. So which combination of charges will cause the change in the balance reading as shown? Now, practically, what happens is this: for there to be an increase in mass of the rod, that means that maybe there are possibilities. Most probably, maybe there is another weight that has been added on mass X, which is not there. But if it is all about the force, then it has to be a repulsion force. That is why there seem to be an increase in force. So it's like there's additional force that is acting on rod X. That is where there's an increase of 0.4 grams. So it must be a repulsion. So either both X and Y are positively charged or both of them are negatively charged. So let's look at the choices. When I look at choice A, X is negatively charged, Y is negatively charged. I don't need to read the next one. I don't want to waste time. So my answer is B. Now, question number two also form part of the list. This paper was found from February, March 2024. Nichrome wire P has a length of 1.0 meters and a diameter of 1.0 millimeters. Second wire, nichrome wire Q, has a length of 2.0 meters and a diameter of 2.0 millimeter. Which statement correctly compares the resistance of Q with that of P? Most of the common question about resistance, you realize that we all know that resistance is directly proportional to L and inversely proportional to the cross-sectional area. We used to have this equation, R is equal to resistivity times L over A, but the use of this formula was removed from the curriculum. But still, these kind of questions are being set. This is putting students into a challenge. They're wondering now, why are we setting questions like this? Yet, the equation that we are supposed to use has been removed. So without even using this equation here, we can look at this. So if we call this P, RP, and then let's now call the other one. So remember, we are talking about diameter. So being a nichrome wire, the assumption is that the cross-section area of the nichrome wire is circular. That means that A is pi d squared over 4. How did I get that? Because we know that cross-section area of a circular surface is pi r squared, but r is d over 2. So if we fix it there, we're able to find A is given by pi over 4 d squared. So therefore, we can rewrite this as Rp is directly proportional to L over d squared. Remember, pi and 4 is they are constant. So when I'm looking about proportionality, I don't need a constant value there. I need a variable. Okay, good. So if I can just fix the values there, I will have 1 meter as the length, 1.0 meter, and then d, which is 1.0 millimeter into meters, that will be 0.001 meters, and this should be squared. Use your calculator. This should give us 1.0 times 10 power 6 times 10 power 6. Okay, if I look at RQ, which is directly proportional to L and inversely proportional to D squared. If I fix that, that will be 2.0 meters over 0.002 meters, because this is in millimeters. So we need to convert to meters. So that will be squared, and we get this as 5.0 times 10 power 5 times 10 power 5. So now if we relate this and this, then you will realize that RQ is actually a half of RP. RQ is basically a half of RP, or RP is twice RQ. If you multiply by 2, then you'll be able to get that. You can able to confirm that by, someone is wondering, how am I getting that? Just take 1.0 times 10 power 6 divided by 5.0 times 10 power 5. So 5 goes here, that is 0.2, while this goes there 10 times, that is 2. So that is where the half or 2 is coming from. And when you go back to the multiple choice, you can able to realize there is no quarter anywhere. 4 times is not anywhere, same as nowhere. So you can able to see clearly the answer is B. So resistance of Q is 1/2 the resistance of P. All right, there's another similar question like that. Maybe we can just look at it. I wish I could have put them together. This one here. So these seem to be very direct, but somehow it's still a challenge. A piece of metal wire X with a uniform diameter has a resistance R. This is last year, May, June, 2020, that is 2023. The second piece of wire Y is made of the same metal and has a uniform diameter. Wire Y has double the cross-sectional area X and has a length of what? A length X. So what is the resistance of Y? So first thing we know is that R is directly proportional to L, inversely proportional to A. For if you're talking about X, let's say this is for X. For Y, let's see the changes. So double the cross-sectional area and half the length. So double the cross-sectional area and half the length. So that means the length will be 0.5 L of the original, that is the one for X. While area is double, that means we're able to have 2A. So that means that RY is directly proportional. 0.5 divided by 2, that is 0.25, and that is L over A. And L over A is Rx, meaning that RY is directly proportional to a quarter. 0.25 is a quarter of Rx, which for this case just called R. So we can able to find our answer as A. Good. So all right, we skip some questions up here. So that is so number 3. In an experiment to investigate the relationship between volume of a sample of air and its pressure, the volume of the sample is decreased and its pressure is measured continuously. This is October, November 2023, variant 2.3. So curve X, as you can able to see on the graph, shows the results that will be expressed for a fixed mass of air at constant temperature. That means this is for ideal gas. So for an ideal gas, we expect the curve for X, okay? Curve Y shows results that are obtained in a particular experiment. So this is now when you're doing the experiment practically, then you get a Y. So what you're seeing here is that now there is a decreased pressure when doing this experiment. Okay, so which row shows 2 possible reasons why curve Y is different from curve X? So this is a question that you don't want to think about. You don't want to think about the answers, but you can go directly to the multiple choice and then do elimination. This is where elimination works without no doubt. So let's find out. Now, temperature of air increases as the volume is decreased. When temperature decrease in volume from here, according to Boyle's law, P is inversely proportional to V, meaning that when there's a decrease in volume, what does it mean? It means there's going to be what? There's going to be an increase in pressure. An increase in temperature also increases pressure, but yet you've seen here clearly pressure has decreased. That means A is out. I don't need to read reason number 2. Part B, the temperature of the air increases as the volume is decreased. The temperature, that is also out. So AB is out. All right, so let's look at part C and D. The temperature of the air decreases as the volume is decreased. The temperature of the air, so that means now C and D, column 1 is correct. So that means I have to check the other side. That air leaks into the container. If air leaks into container, that means there's going to be more number of particles. And that means the rate of collision with the walls of the container is going to increase, thereby increasing pressure. So when we increase the number of particles, we expect pressure to increase. And that means our correct answer is C. When air leaks out, that means we are going to have less number of particles colliding with the walls of the container. So the frequency will decrease, and that means pressure will decrease. Question number 4 seems to be very easy. I know it is very easy, but then why is it always a challenge when dealing with vectors? I think because probably maybe we are not that patient, or we don't want to look at vector into practicality. You know, if you have this is the object here. So there's a force that is pushing it this way, and there's another force that is pulling it this way. You know what is happening? Most likely, so if there's a force pushing it this way, and there's another force pushing it this way or pulling it that way, most probably this particular object may move in between the forces. So I want to be looking at vectors. Sometimes if you look at a vector like, for example, velocity, look at vector like acceleration, momentum, they don't make somehow sense. But then if you have an idea of how force works, because that is generally how vectors work, you know, force is a vector quantity. Force is more practical than acceleration, momentum, you know, any vector like velocity. So when you talk about pulling, pushing, you can have an idea where the object is. I have 2 ways I can able to put this. So this kind of question, I don't want to eliminate first. I want to look at the possible solution. So the possible solution is that I can have this U. I have U here, top there, and then I have V here, down here. So this is U, this is V. Obviously, I just need to connect. I just need to connect from the start to the last. I'm using a new graphic tablet, so I'm not used to this one. That's what my sketching is, but anyway. So you can able to see clearly the direction. What if I have V here, this is V, and then U here? You can able to see it still have to be parallel. So whatever you're looking for, we are looking for a vector in this direction. A vector in this direction. So if I look at all this, A is out, B is out, D is out. So our correct answer is C. So we see that is what you're supposed to be doing. So this should never appear in any of my list as most challenging questions. All right, number 5. There's always something here about momentum. Many students wonder what happens if a body is changing its velocity. So finding the change in momentum when the body is changing the direction. Let's find out this one here. So a ball of mass 0.50 kilogram falls and hits the floor as shown. It rebounds at a speed. So remember, you can decide. So if I take before collision, let's say the body is moving downward, I decide that this is negative. That means that this must be positive. Remember, I'm the one deciding. What I know is that I need to know what negative means, what positive means. For this case here, my example here, the negative means that when the body is moving downwards, and the positive means when the body is moving upward. So the collision between the ball and the floor lasts for 0.50 seconds. That is the time of contact. What is all the time of impulse? What is the average force acting on the ball during the collision? So, so force is given by change in momentum. That is mv minus mu divided by time. So I just want to use m into v minus u over t. So m is 0.5. V is our final velocity is 8, which I've taken to be positive, minus negative 10. Minus negative 10, and this divided by time, which is 0.5. So I will have 8 minus negative 10. This becomes a plus, so that will be 18. 18 times 0.5. Of course, this 0.5 cancels this 0.5. That means our answer is 18 Newton. And you can able to see clearly, this is a positive value. And positive, according to my diagram, means the body is moving upward. So it is 18 newtons acting upward. That is how we are supposed to be doing such kind of analysis. Now, in this question, this is also one of the very interesting questions, which I think you need to visualize it practically. And that is why I like physics. It is all about practical. So if we look at this, a truck is towing a car along a straight horizontal road at a constant speed. Now there's a driving force here. Let me call it FD. And of course, because the car is being dragged, it contributes to the drag force. So let me have this as FR. When the body is moving at a constant speed, what does it mean? It means that the resultant force is 0. It means that FD must be equal to FR. In other words, the resultant force is 0, and therefore acceleration is also 0. That is what it means. Now, the rope breaks. When this rope breaks, you can able to see clearly. Remember, the car is being dragged by the truck. That means the car contributes to the drag force, this FR here. So if it is cut, that means that FD is going to be much greater than FR. And therefore, we are going to have a resultant force which is positive, since FD minus, there will be this drag force here will be less, because maybe just due to the air resistance, but not because of the car. So if the resultant force is positive, then according to Newton's second law of motion, F is directly proportional to acceleration, or the other way around, acceleration is directly proportional to the resultant force and occur in the same direction as the force. That means if the drag force is going to be the right, the acceleration must be to the right. I look at this, it cannot be left, it has to be right. But then now the driving force is greater than the resistive force. The answer is C. For the benefit of my eyes, let me just read part D. The driving force is smaller. No, it is not smaller. If it was smaller, it would have gone to the left. All right, we've done number 7. So let's look at one of another challenging question that students cannot able to predict, so, or to analyze keenly. So please, when you see questions like this, don't rush. Visualize it practically. So a train is traveling horizontally in a straight line. A book is on a table in the train. Okay, the diagram shows all the forces acting on the book. How is the train moving? How is the train moving? All right, now let's analyze. I can see here by the look of the magnitude of the contact force and the weight, the contact force balances the weight. That means that this body cannot move downward, cannot move upward, because the vertical forces are balanced. Let's look at the horizontal forces. The horizontal forces, they're not balanced because we have friction force that is acting in this direction. And if the friction force is acting in this direction, that means the book must be moving to the left. And if the book is moving to the left, then for that to happen, the train must be accelerating. The train must be moving at a higher speed compared to the book. Like imagine yourself sitting in a car and then the driver starts the car without you knowing. What happens? Or maybe increases speed just to overtake. This is so nice on motorbike. Some people make a mistake. They're on they're on passenger seat on a motorbike and they're there on the phone and they're not holding anything. So maybe the rider wants to increase the speed for any reason, and then you find yourself jerking backward. But if the vehicle or the motorcycle is moving at a constant speed, then everybody in that particular vehicle will be moving at the same speed. So that means the train must be moving forward at a higher speed than the book. That is where the book tends to jerk backward. And it has to be acceleration. So the body cannot move at uniform speed. If they're moving at uniform speed, then the magnitude of friction will not be there because it will balance the reaction force the other side that is acting on the opposite side. So there will be zero horizontally. So it has to be accelerating, but then the train is accelerating to the right of the diagram. I hope it makes sense. As you can able to see this gentleman here. So if the driver increased the speed, thank God he was holding. Otherwise, it tends to move backward. So if you don't visualize this kind of question practically, you cannot get it. Another interesting question is this. The diagram shows an AC generator. The graph shows the potential difference PD between points X and Y plotted against time. All right. So the positive value of PD indicates that X is more positive than Y. Which diagram shows the position of the coil at point P on the graph? Now at point P, this is when we have maximum. So this point and here, this and this and this is where we have maximum EMF being induced. So that is where we have the maximum EMF being induced. And that particular point is only when we have A or C. A or C. That means when the coil is perpendicular, that is when we have the minimum induced EMF. So that means this is out, this is out. So the only thing we need to check on is just the connection here and connection here compared to what you're seeing on the diagram. What you're seeing on the diagram, this, you see this, it should be the same. That is why, if you look at it keenly, that is why our answer is C as the correct answer. So maximum, that is what you need to know, that for us to have EMF induced at a higher rate, so the coil moves very fast in horizontal position as compared to when it's vertical, because vertical is momentarily stops before the next. It seemed to be direct, but somehow very challenging. So an electron moves into a uniform magnetic field. This is a question from 2021, May, June, variant 3. The arrow shows the initial direction of the motion of the electron. The direction of the magnetic field is into the plane of the page. So electron is in this direction. The reason why this question is one of the challenging questions is because we want to look at electron and current like things which are very different. But this is all about the motor effect. So if you don't find an electron here, next time you may find beta particles under radiation. So the same concept will apply. Remember, when you're looking at a simple circuit, so we have maybe, let's say, a bulb here. So convection current will always flow from positive to negative, while electrons flows in the opposite direction. And when now we use the Fleming's left-hand, because this is about motor effect. The moment you see a charge into the field, or there's current, there is in a conductor current in the field already, there's a source of battery, or there's a charge, not source of battery, but source of power. That means we're dealing with what? The motor effect. So this, what it's supposed to do is this. Electron is moving this way. This second finger here, the second finger shows the direction of the current, conventional current. This points the direction of the magnetic field. So as you can be able to see my finger here, you see. So the first finger will point the direction of the magnetic field because that is what cross indicates. So this points that. But then this is the direction which will be opposite to the direction of the electron. So what happens? I twist it like this. And if I do like that, then you will be able to see that what? That this electron will be deflected down the page. Will be deflected down the page towards the bottom. So into the page, out of the page, towards the top of the page. Our answer is C. And it's all simple reason as that. This applies to beta particles. This applies to any negatively charged electrons. If it is positively charged electron, of course, we have positively charged electron. You'll be able to realize that in year 12, but anyway, which are called positrons. No, for now, let's just stick to what we know. So if there's any positively charged particle, it will be in the same direction as this. All right, I don't know why this is one of the challenging questions, but let's find out. The graph shows how the pressure due to the liquid varies with the depth beneath the liquid. The gravitational field strength G is given by that. We have a graph of pressure due to the liquid plotted against the depth beneath the liquid surface. What is the density of the liquid? So what we always know is that the pressure exerted by the weight of the liquid at the bottom of any container is given by this H rho G. So we are plotting a graph of P against H. So P against H. So I want to write the other ones in different colors so that you see. What I'm trying to write here is that this is like Y is equal to mx. So that P is our Y, H is our our X. Meaning the gradient of this graph will give us what? Will give us P rho G. Let's find out. Let's find the gradient of this graph. Let me use this particular point here. Because it is starting from the origin, I can just choose, as long as a line is passing through the origin, I can choose just 2 points, just one point on the graph and find the gradient. So the gradient here, M, will be 4,000 divided by, so I'm choosing that point, divided by 0.5. If you divide that, that will give us 8,000. Now this 8,000 should be equal to rho G. So rho G, that is times 9.8. So I'm going to divide by 9.8, divided by 9.8. So that means our density should be, so density should be 8,000 divided by 9.8. And our answer is about 816. So that is round up to true significant figure. That will be 820 kilogram per cubic meters. So you see why it is a challenging one. All right. I don't know why moment of a force somehow students always find it to be challenging, but I hope it is not you. But if you're the one, let's look at this one here. Question number 12. So a 20-meter long uniform bridge of weight 100 kilonewton is supported at each end by pillars as shown. So I want to teach two concepts here. One is about moment, another one is about prefix. So I had some of my friends saying that, oh, they forgot, in the paper form, that you guys did for this particular year 2024, there was a question about nanosecond, something about nanoseconds, and they were not able to know what nano means. So prefix is very, very important. So here, the unit of weight is Newton. Anything before Newton or after Newton should be, anything before Newton is a prefix. So the weight here is 100,000. K is 1,000. All right. The pillars exert forces T1 and T2 on the ends of the bridge. What are the values of T1 and T2 when a bar of that is on the bridge? So the bar of 24 kilonewton, 5 meter from the left. So we want to find. So we're going to apply. We're going to apply the conditions for a body to be in equilibrium state. Condition number one is that the principle of moment must apply. What does that mean? Must apply. What does it mean? It means that the resultant moment must be zero. Another condition is that the resultant force must also be equal to zero. So we're going to apply those two conditions in this particular question. And this question here, we don't know where the pivot is. And so we can decide where our pivot is going to be. I like using the pivot at the end, either this or this side here. But let me call here maybe A. So I want to use the pivot at point A. If I use the pivot at point A, you will realize, because moment, let me use capital M for moment. Moment is force times distance. If I take moment at this particular point here, that means the moment due to T1 will be zero. Why? Because the distance from the pivot, yet the force T1, tension T1, is acting at that particular point. No, it's not tension, but just force is zero. That means moment due to T1 about point that I've selected is zero. So I only have two forces. So if you look at T2, the moment due to T2, if you assume there is no this force and there is no this force and only concentrate on T2, then T2 will make this beam rotate in anti-clockwise direction. That means moment due to anti-clockwise will be T2 times the distance from the pivot, which is that. So that will be 20 T2. When you look at about point A, our point here that we are using, we have two forces, and these forces, all of them, if they're allowed to act on the bridge only, then they will make the bridge to rotate in a clockwise direction. That means along the clockwise direction, we have two moments. So we have this 24,000. I could have just used 20 kilo, the kilo without changing. I can use that, but anyway, to avoid anything. So 24,000 times 5. Remember, we have been given 5 from the left pillar, so that is 5. We add to 100,000 times, because this is if it is a uniform a uniform bridge, then the weight must be acting at this geometrical center. So that means one side will be 10, so I multiply here by 10. So this is Newton. So therefore, we'll have 24 times 5, that is 120,000. 120,000 100,000 plus this 100,000. 100,000 times 10, that is 1,000,000. So that gives us 112,0,0,0. This should be equal to, so remember, clockwise moment is equal to anti-clockwise moment. So this moment here should be equal to the moment of 20 T2. So T2 should be that divided by 20, which will give us 56,000. So 56 kilonewton. Yeah. Another thing, now we have applied the concept of number one, resultant moment must be equal to 0. So we are applying the other concept about the resultant force. So we have here upward forces against the downward force, but because it is in equilibrium state or it is balanced, then T1 plus T2 should be equal to 24 kilonewton plus 100 kilonewton. That means that if I want T1 will be equal to 24 plus 100 minus the weight of T2 minus 56. So that is 124 minus 56. I get 68. I get 68. It was multiple choice. I could have just selected A automatic. But wait. No, it's not A. It is C. Yeah, T2 is 56. This is 68. I could have just collected directly, by the way. When I got this to be 56, I know you were also wondering, you were just waiting for me to finish. When I got T2 to be 56, this is the only 56 on this side. So automatically, without wasting time, I could have gotten the answer. But it's always good to double check. Maybe you may make a mistake and then you don't find the answer on the other side. All right. There's a very interesting question here, almost similar to a concept we have just learned about. The diagram shows horizontal wire in a magnetic field. This is a paper of October-November 2021, variant 21, variant 1. So the horizontal wire is firmly held at each end, not shown how it is held, but it cannot move. Okay. When there is no current in the wire, the reading on the balance is 0.35. Reading on the nene is 0.35. Okay. There is a DC current in the wire as shown. So DC current is flowing. So the moment you see a dot, when you see a dot, that means current is from the pitch into the eye. So if you're looking at your paper like this, the current is up like this. So this is about motor because there's already current and there's magnetic field. So that means if I'm supposed to put this way, the first thing that I'm going to do is to ensure that what? This is pointing my eye. But if the paper was here, then this could be pointing up like this. But anyway, because this is the screen, so because this is a screen, so my finger, the second finger is supposed to point my eye because it is out of the page. And then this is supposed to point the direction of the magnetic field, which is towards the south. So I just do like this. You see that? So the magnetic field, so the force will be acting upward. Now we have confirmed where there is a force acting upward. There's a force acting upward on the conductor. And whenever there's a force acting upward, according to Newton's third law of motion, there will be a reaction force acting downward. So what does it mean? Remember, there is the weight of this magnet, which is already 0.35. So this reaction force will have like an additional force on the magnet. And so we expect a reading more than 0.35 grams. So that is why the answer must be a B. That was a tricky one. Now, the circuit diagram shows a DC power supply connected to two resistors, R1, R2, and 4 diodes. So a diode is a special resistor which allows current to flow in one direction. So in this case, because these are DC, so current will flow in this direction. So once it cannot go through here, why? Because this diode here will not allow this current to flow. It only allows the current to flow if the flow of the current is the same direction as its arrow. So that means the current will flow here and then come here. When it comes here, it cannot flow here. It will be reverse biased, so it won't allow current to flow. Therefore, this current will flow here. When it reaches here, it will follow here and then goes through R2. So which statement is correct? There is a current in R1 and there's a current in R2. This is correct. Let's see if there can be two answers which are correct. There is a current in R1, but not, that is wrong. There is no current in R1, but current, no. There is no current, so our answer is A. At least there are no two answers. Number 15, 4 balls with different masses are dropped from the heights as shown. Air resistance may be ignored. Which ball has the smallest average speed? So if air resistance is ignored, the interesting thing here is this, that the GPE, the transfer of energy, is transferred to kinetic energy. So meaning that we have mgh is equal to a half mv squared. So m cancels. So you will realize here that v squared is gh. So v here depends on g and h. And since this experiment is done on the same place, so therefore g is, so v squared is directly proportional to h, meaning increase in h increases v. D has the highest speed. That means the one that has the lowest value of h should be having the least speed from this confirmation here. So our answer is A, not D. D has the highest speed, so it doesn't depend on the mass. All right. All right. This should be our last one. Now, the circuit shown can be completed by inserting components at X and at Y. The completed circuit is a potential divider in which the potential difference across the component Y increases when the temperature increases. So this is October, November 2023, that is last year, variant 22. So which row shows the components X and Y? There is something about temperature. When we talk about temperature, how it affects a component, and we look at here, it is either thermistor. So we're dealing with a thermistor somewhere here, a thermistor somewhere here. So that means without even looking at the reasoning, A and B are out. Our answer is either C or D. Let's find out. So we want a component whereby if we place at X and another one at Y, when temperature increases, the potential difference across Y increases. Now remember, what is a thermistor? A thermistor is a special type of resistor whereby increase in temperature increases its resistance. That means component Y cannot be a thermistor. It cannot be a thermistor. Why? Because potential difference will increase if R increases. Because when they are in series, if resistance increases and the same number of charges supposed to flow through it as the other one, that means more work has to be done. And if more work has to be done, that is now when resistance increases. So when resistance increases, that means PD must increase. But when you increase temperature, the resistance of thermistor must decrease. That is why X must be a thermistor. This must be a thermistor here. And this will just be any other resistor. That is why, so if X is a thermistor, our answer is D. Guys, once again, if you have any question, feel free before you do that exam that you are waiting for, whether it is internal exam or these May, June exams, which is going to be like in 2-3 days. That's why I'm saying that please share this video. It may be able to help someone that is preparing for this exam. If you're preparing for exams in October this year or any other year, when you see this video, I want to wish you the best. If you have any question, any challenging topic, always suggest in our comment section there. I will be able to make for you a free video. But just in case, there are some videos that I've done, there are some lessons I've done together with notes, video, practical that is recorded, solve past paper questions, topical organized, assignment that is organized, well organized. You can able to find that at inolearnnetwork.com, which you can able to see on your screen. Until another day, I want to wish you all the best and thank you for sharing this video. How I wish you could also subscribe. Subscribe?